and we're going to talk about factoring next. All right, we've been putting these polynomials together. We've been adding, subtracting, and multiplying and dividing them. Now it's time to tear them apart. So factoring, to factor a polynomial is to write it as a product. Now remember what that word product means. It means multiply. A factor of a polynomial p, and that's just what they call a polynomial, sometimes by a big letter, is a polynomial that can be used to write the polynomial p as a product. In other words, we're going to take them and break them up, bust them up. A factorization of a polynomial is an expression that names the polynomial as a product. So let's take a look at that with some examples here. We want to, in factoring, let's take this monomial, negative 18x to the fifth, and we want to write 3 factorizations for this monomial. All right, now what's a factorization? It means if I take and write this as products, I'm going to come out with negative 18x to the fifth. So one such factorization would be 9x to the second power times, can you tell me out there? Think about it. All right, I'll give you a chance here. All right, you thought about it? Here we go. 9 times what gives you negative 18? Negative 2. X squared times what gives me x to the fifth? Now there's power rule number 1. Whenever you multiply same bases, add the power. So x squared times x cubed would give me x to the fifth. So this would be one factorization of this monomial. And I'm going to write some more. All right, so what if I started out with some other numbers and variables here? What if I just said 6x to the fourth? What would you tell me? Well, to get to the negative 18, 6 times negative 3. To get 5 x's up here, we're how many x's short? Some of you might say the instructor here is something short, a few quarts, but that's all right. X. So we'll end up with 5 x's there. And one other one just for good measure. How about I'm going to get real lazy here and put negative 1 as a factor. Then to get the 18x to the fifth, we can write 18x to the fifth. So y'all out there in the audience, you could probably come up with 10, 12 more if asked to, with different variable powers and different numbers to total this monomial. Lots of different ways to get there. Okay, let's look at the next graphic real quick here. Now, what if we want to factor something with more than one term, more than a monomial? We want to talk about the GCF, the greatest common factor. That's what GCF stands for. The first and foremost rule of factoring is to take out the GCF. Yes. And when you do that, step 2, you're going to divide each term by that common factor and put what's left in the parentheses. So this is going to leave us with the GCF times what's in the parentheses. So let's look at some examples with that. All right, factoring the GCF. So first example is a binomial, x squared plus 6x. Now, what do these two terms have in common? The greatest thing I could take out of either one is, well, a single x. I could pull an x out of each one. And if you see that's what the two terms have in common, once you see that's the greatest common factor, you can go ahead and put it right underneath each term and divide each term by that if you want, and then put what's left in the parentheses. So x squared divided by x is x, plus 6x divided by x is 6. So you might recognize this as one of our properties kind of in reverse here. If we distributed or multiplied the x through, it would definitely check and give me what's up here. All right, so you can check this as well. These are kind of nice. All right, next example, a little bit more difficult. 10x to the fifth power minus 25x squared. All right, what can we take out of this binomial? Well, the largest number that can go into 10 and 25, 5. The largest number of x's I can take out of either term would be an x squared. Now, sometimes people go, Young, why can't you take an x to the fifth out of both of these? Well, let's face it, folks, they both don't have an x to the fifth in them to take out. You know, it's kind of like my bank account. There ain't nothing in there, you can't take it out. So anyway, go ahead and once you identify that greatest common factor, which in this case these two terms have 5x squared in common, then you can go ahead and write that 5x squared right underneath each one and put what's left in here. So I think this kind of lines your ducks in a row up as well. So 10 divided by 5 is 2x to the third power minus 25x squared divided by 5x squared. The x squares cancel out, leaving you with minus 5. Right? So we can distribute that back through, and we'll get right back to where we started. So factoring the GCF out, you might even want to make a note here as like undistributing. Undistributing. I don't know if that's a good word they use in textbooks, but we'll use it here. All right, now let's look at this trinomial. I tried to make some larger powers and scare you out there. I hope you're not scared. What is the largest number of x's I could take out of each of these three terms? Well, the most x's in all of them, the common ones, that's why they call it greatest common factor, would be x to the fourth power. The greatest number of y's I could take out of each one would be y to the fourth power. So x to the fourth, y to the fourth will come out of each of the three terms in the trinomial. And then what's left will go in here. Now, a lot of students try to do this in their head. They try to go ahead and subtract powers and stuff in here, and they do it in their head, and they get in trouble. So you have to be kind of careful. All right, so that's why I like to just take a second, time this back there. My camera crew always times stuff for me. I mean, it doesn't take but seconds to do. Write that right underneath, and then you've got your ducks in a row. You can subtract the powers here and make sure you don't make mistakes, and you'll have x to the fourth y squared, 4 from 8, 4 from 6, can't miss them, minus x to the third y, plus, now wait a minute here, Young, the x to the fourth cancel out, the y to the fourth, what's left? Well, we could write x to the 0, y to the 0 power here. Now, why don't we? Because we know anything to the 0 power from our power rules is 1, so it's really just plus 1 on the end. So that would be the final answer there in factoring. All right, more examples. All right, so we want to look at these. Now, you have to be careful here on these. Beware, all right, because sometimes students get this and they say, gee, Young, what goes into 48 and 240? And the answer is lots of numbers. 2, 4, 6 goes into them, 12, 24 goes into them. But I think the largest number that goes into them is 48. But let's say you don't see that out there. Let's say you don't see it. We'll go ahead and say, and I'm going to deliberately miss this one. I know that's going to bother you. I'm just going to take 12 out of the numbers, and I see an x is in common, so let me sneak that x in there. All right? Watch what happens here. If I divide each term by 12x, I'm left with 4x to the third, dividing the numbers and subtracting the powers on the variables, minus 20. Now, what's wrong with this picture? Well, I factored it. I could multiply it through and get what I started with. But notice there's still something in common left in the parentheses. What? Yeah, you could take a 4 out. See, so if you don't get it in the first round, we'll get it down the stretch. So we could have taken an additional 4 out of there, which I'm going to yank out of there now, and then just keep dividing by 4. So if you factor the GCF and do it correctly, not only will it distribute through, but there'll be nothing left in common in here, and we'll talk about that more in future lessons, all right? So this will be a good place to watch out for things. So the final answer here will be multiplying the 4 by what's out here. 12 times 4 is 48x, and then what's in here, you end up with x cubed minus 5. Now, I know that this is correct because when I multiply it back through, I get what I started with, and there's nothing left in common in here. So that's what we're going to look for and talk about more in the next episode. All right, so in closing, now that you have the notes from the graphics, examples, and understanding, your mission is clear. Find similar problems in your textbook or class, practice until you feel comfortable with the material, and then when you think you got it, practice a little more. Remember that math is like a bank. What you put in is what you can take out come test time. Take care, and we'll see you next time.